Ancient Greeks, Romans, and Jews were known to chill wines and juices as a treat during the summer months. This practice evolved into fruit ices and, eventually, frozen milk and cream mixtures. But it wasn't until the 20th century that ice cream became available to the common man. As the Industrial Revolution brought electric power, steam power, and mechanical refrigeration, the ice cream market grew to astronomical size, with an estimated market size of $81.8 billion in just the United States. So how is it made? The process begins with cream, which arrives at the factory in refrigerated trucks and is then stored in refrigerated silos, kept at a constant 4 degrees Celsius. Because cream is a dairy product, it carries a high risk of contamination through bacteria. Keeping it at a lower temperature during transport and storage helps maintain its freshness and quality. The silos feed a high-speed mixer that mixes the cream with other ingredients. The main dry ingredients are powdered skimmed milk and plant-based stabilizers and emulsifiers. Stabilizers prevent the ice cream from crystallizing, and emulsifiers allow the mix to bond with air during the whipping process. The other ingredients are sugar and corn syrup. After about 3 minutes of mixing, a pumping system moves the mixture into specialized pasteurization machines. The most commonly used machine is called a plate heat exchanger. It consists of a series of stainless steel plates that are pressed together with gaskets, creating channels for the mixture to flow through. The plates have a large surface area, allowing for efficient heat transfer. During pasteurization, the mixture is pumped into one side of the plate heat exchanger while hot water or steam is circulated on the other side. The heat from the hot water or steam is transferred to the mixture through the plates, effectively heating it to the desired pasteurization temperature. The tanks keep the mixture at 72 degrees Celsius for half an hour, killing any bacteria and activating the stabilizers. Then, the factory homogenizes the mixtures, a process that breaks up the fat globules, giving the ice cream a smooth texture. During homogenization, the hot mix is forced through small openings at high pressure to reduce the liquid fat droplets to a small, uniform size. Homogenization is integral to ice cream's smooth texture and prevents fats from churning in the later freezing stage. After homogenization, the base mixture is often aged for a certain period, typically several hours to overnight in refrigeration. This allows the flavors to meld and the texture to stabilize. The base mixture is cooled down to a lower temperature, usually around 4 degrees Celsius, 39 degrees Fahrenheit. Chilling helps reduce the freezing time and ensures a smoother freezing process. The chilled base mixture is transferred to an ice cream machine, which is a continuous freezer. The machine freezes the mixture while simultaneously churning it. The churning incorporates air into the mixture, increasing its volume and creating a lighter texture. In fact, the volume of the ice cream can increase by 60 to 100% simply because air is added. The incorporation of air is crucial. It makes the ice cream softer and slows the melting process. Without air, ice cream would be too hard to eat. The temperature inside the machine is set between -5 to -8 degrees Celsius, 23 to 18 degrees Fahrenheit. During the freezing process, additional ingredients such as chocolate chips, nuts, cookie dough, or fruit pieces can be added. These ingredients are typically added through specific openings in the machine, ensuring even distribution throughout the ice cream. Automatic filling machines drop pre-printed pint or half-gallon size cardboard cartons into holders. The cartons are then filled with pre-measured amounts of ice cream at the rate of 70 to 90 cartons per hour. The machine then places a lid on each carton and pushes it onto a conveyor belt. The cartons move along the conveyor belt where they pass under an inkjet that spray paints an expiration date and production code onto each carton. After the imprinting, the cartons move through the bundler, a heat tunnel that covers each cup with plastic shrink wrapping. The packaged ice cream is moved to a blast freezer, where it is rapidly frozen at temperatures below -18 degrees Celsius, 0 degrees Fahrenheit. This freezing process helps maintain the texture, quality, and shelf life of the ice cream. It's then transported and stored in supermarket freezers or ice cream shops until it's purchased by customers. I don't know about you, but ice cream is my favorite sugary treat. And if you are wondering how sugar is made, check out this video. Today, the ketchup industry generates $35 billion in revenue. So how is it made? The process begins with harvesting fresh tomatoes from the farms. This is done using specialized machinery that integrates various functions like cutting, shaking, sorting, and loading. All of the machine's movements and functions are powered by a hydraulic system. After the tomatoes are harvested, it's time to transport them to the production facility. Ripe tomatoes are received at the production facility and sorted to remove any damaged or unripe ones. They are then thoroughly washed to remove dirt and impurities. Next, the washed tomatoes are crushed or chopped into small pieces using industrial-grade equipment, such as pulpers or grinders. This process breaks down the tomatoes into a coarse puree. The tomato puree is then preheated to a specific temperature to loosen the skin and facilitate separation. Some manufacturers use steam injection or other methods to achieve efficient heating. The preheated tomato puree is passed through equipment, such as a peeler or centrifugal separator, to remove the skin and seeds. This step helps achieve a smoother texture and removes any undesirable components. Tomato puree production is a crucial process in the making of tomato ketchup. Once it's done preparing, it's packaged in airtight containers and stored in a warehouse. It's important to note that tomato puree is made individually because separating its production provides flexibility in customizing the flavor and consistency of ketchup. Tomato paste's longer shelf life and efficient storage also make it a convenient intermediate product. As the ketchup making process starts, crates of tomato paste weighing 1,300 kilograms are transported from the warehouse using automated forklifts. The crates are opened and then go to the paste dumper, where huge rolling pins squeeze the paste out of the package. After the paste has been extracted, it sits in the storage bin, where it's mixed with water to give it a smoother consistency. This makes it easier to transport to a storage tank, where it will sit until moving on to the ketchup kitchen. The diluted puree arrives in the ketchup kitchen, where it's mixed with precise amounts of sweeteners, vinegar, salt, spices, and flavorings. Most spices are added early in the cooking process. To avoid excessive evaporation, volatile spice oils and vinegar must be mixed in later. Onions and garlic can be mixed in with the spices, placed in a separate bag, or chopped and added to the pulp. Salt and sugar may be added at any stage of cooking, though it is better to add sugar later to prevent burning. The mixture cooks for about 30 to 45 minutes and is circulated by rotating blades installed in the cookers. Now it's time for packaging. Most ketchup brands use keystone-shaped plastic bottles to store their ketchup, and the design was developed by none other than Henry Heinz. The curved neck encourages the ketchup to flow out smoothly, while the narrow mouth minimizes the amount of ketchup exposed to air, preventing it from turning brown. The added benefit of having a transparent bottle is that the customer can see what's inside and rest assured that the product is fresh. The ketchup is dispensed into the bottles with the help of a filler. The filler checks the weight of the empty bottle and then fills it to desired weight by pouring in ketchup. Once the desired weight is reached, the bottles are immediately sealed to retain the freshness of the product. The containers must be cool to prevent flavor loss through stack burning, which occurs when ketchup stays at high temperatures after cooking is complete. Containers of ketchup may be cooled in cold air or cold water. Finally, the ketchup containers are labeled and coded with product information, including ingredients, date, location of manufacture, and shelf life. The bottled ketchup may be inspected again before shipping. The entire process of ketchup manufacturing generally takes 2 to 3 hours. A typical ketchup factory produces about 1.8 million ketchup bottles per day. No wonder the market is so huge.